Alright, so the one thing I wanted to talk about regarding torque still is this idea of things being balanced. So if we have torque on an object, then the torque will cause angular acceleration, just like an overall force would cause acceleration on the center of mass of an object. So in regular physics, we know that F net equals ma, because the net force is going to cause acceleration. So in similar fashion with torque, a net torque is going to cause a net angular acceleration. But the part that I want to focus on today is the idea that if the net torque is zero, then you have zero acceleration or zero angular acceleration, and the object is going to stay balanced. So the example I'm going to talk about here is a seesaw. So imagine you have an object on one end and an object on the other, so object 1, object 2. Depending on their masses and depending on where you place them, you can balance them so they're not rotating up or down on either end. The location of the object is going to depend on their masses. So if they weigh the same, then you're going to place them the same distance from the fulcrum. However, if one is heavier, then you need to place it closer to the fulcrum so it doesn't overwhelm the other side. So the equation that we use for scenarios like this is basically the torque on the left has to equal the torque on the right. So if the acceleration on the left equals the acceleration on the right, one would be clockwise, one would be counterclockwise, then your overall torque is zero, your overall acceleration is zero, and the object stayed balanced. If we now put in our equation for torque, which is Rf, so the distance on the left and the force on the left have to equal the distance on the right and the force on the right. Okay? So if I now just quickly add numbers to this, so let's say our object on the right is 50 kilograms and our object on the left is 30 kilograms, and let's say that our object on the right is 75 centimeters or 0.75 meters from the fulcrum. The question is, how far from the fulcrum does the left object need to be in order to keep this balanced? So if we apply that to our equation, so we're solving for RL, which means radius right times force on the right divided by force on the left. So our radius on the right is 0.75 meters times our force on the right. The force is the weight, which is mass times gravity, so 50 times 9.81 divided by 30 times 9.81, and you can see that the 9.81 is going to cancel out anyways. So for us it is 0.75 times 50 divided by 30 is going to give you 1.25 meters. So if I want to balance these two objects, then the one on the left needs to be 1.25 meters from the fulcrum, whereas the 50 kilogram object on the right is only 0.75 meters. So again, we haven't talked about angular acceleration yet, but you can still do these types of questions, and I hope you understand them. Basically, torque on the left has to equal torque on the right in order for the object to not spin, not move, and basically be balanced.